The cosmos, once a distant spectacle, made its presence felt here on Earth. The vast expanse of space with its myriad of celestial wonders suddenly seemed much closer and more tangible. It was as if the universe itself had reached out to remind us of its omnipresence and power. On date of recent solar storm, the Sun, our life-giving star, unleashed a powerful solar storm. This event was not just a random occurrence but a significant cosmic phenomenon that had far-reaching implications for our planet. Sunspot AR 3664 erupted, flinging a wave of charged particles towards our planet. These particles traveled across the vastness of space, eventually colliding with Earth's magnetic field, creating a spectacular display of natural fireworks. This wasn't just any solar event, it served as a cosmic wake-up call. The intensity and scale of the storm were unprecedented, reminding us of the sun's immense power and its potential to influence our daily lives in profound ways. Auroras, typically confined to the polar regions, danced in vibrant hues across lower latitudes. These mesmerizing light displays, usually seen only in the Arctic and Antarctic, were now visible in places where they had never been seen before, captivating millions. Social media buzzed with stunning images of the night sky ablaze. People from all over the world shared their experiences, turning the event into a global spectacle. The beauty of the auroras brought people together, fostering a sense of shared wonder and amazement. Yet behind the beauty lurked a stark reminder of our planet's vulnerability to the sun's temperament. The solar storm disrupted satellite communications, caused power outages, and highlighted the fragility of our technological infrastructure. The recent solar storm, while visually captivating, was a stark reminder of our interconnectedness with the cosmos. It underscored the delicate balance between our technological advancements and the natural forces that govern our universe. It underscored the fact that even in our technologically advanced age, we are not immune to the sun's powerful forces. Our satellites, power grids, and communication systems are all susceptible to the whims of solar activity. This event, a prelude to the approaching solar maximum, serves as a powerful call to action. Scientists and researchers are now more focused than ever on monitoring solar activity and predicting future storms to mitigate their impact. We must prepare for the inevitable, for the sun's energy, while life-giving, can also be disruptive and potentially destructive. By investing in resilient infrastructure and advancing our understanding of solar phenomena, we can better protect our planet and ensure the safety and continuity of our technological systems. To comprehend the potential impact of solar storms, we must first understand their genesis. These powerful phenomena originate from the Sun, our closest star, which is a massive ball of hot plasma and magnetic fields. Solar flares, sudden bursts of energy from the Sun's surface, are often accompanied by coronal mass ejections, or CMEs. These flares are like gigantic explosions that release a tremendous amount of energy, equivalent to millions of nuclear bombs detonating simultaneously. These CMEs are colossal clouds of charged plasma hurled into space. They consist of billions of tons of solar material, including protons, electrons, and heavy ions, all moving at incredible speeds. Imagine, if you will, 1 billion tons of matter, a fiery tsunami of protons and electrons, traveling at millions of miles per hour. This massive wave of solar material can travel vast distances across the solar system, sometimes reaching Earth. When these charged particles reach Earth, they collide with our planet's magnetic field. This magnetic shield, known as the magnetosphere, protects us from the full brunt of these solar storms. This interaction triggers geomagnetic storms, disrupting radio communications, and even posing risks to our power grids. These storms can induce electric currents in power lines, potentially causing widespread blackouts. The recent solar storm, though not as powerful as some historical events, caused noticeable disruptions. Satellites in orbit experienced interference, and some communication networks were temporarily affected. It served as a tangible reminder of the sun's immense power and the potential consequences of our technological reliance. As we continue to advance technologically, understanding and preparing for these solar events becomes increasingly crucial. The recent solar storm, while significant, pales in comparison to the Carrington Event of 1859. This event, the most intense geomagnetic storm ever recorded, serves as a stark warning from history. Telegraph systems, then at the forefront of technology, went haywire, sparking fires and delivering electric shocks to operators. Auroras, typically a polar spectacle, were witnessed as far south as the Caribbean. The Carrington Event, though a relic of the past, holds profound lessons for our modern world. Imagine such an event occurring today. Our technologically dependent world, from GPS navigation to global communication networks, would face unprecedented disruption. The economic and societal costs are almost unfathomable, highlighting the urgent need for preparedness and mitigation strategies. Our modern world is interwoven with intricate technological systems, creating a complex web of connectivity and convenience that we often take for granted. Satellites orbiting high above connect us globally, enabling everything from GPS navigation to international communications and weather forecasting. Power grids, the arteries of our civilization, deliver essential energy to our homes, businesses, and industries, ensuring that our daily lives run smoothly. Yet these systems, marvels of human ingenuity, are vulnerable to the whims of the sun. Solar flares and storms can unleash powerful bursts of energy that travel across space. Solar storms like the recent event can disrupt satellite operations, affecting communication, navigation, and even weather forecasting. These disruptions can have cascading effects on our daily lives. The risks extend beyond our orbital infrastructure. Power grids on Earth are also at risk, as they can be severely impacted by geomagnetic storms. Power grids, susceptible to the fluctuations induced by geomagnetic storms, could experience widespread blackouts, leaving entire regions without electricity for extended periods. The potential for cascading failures where one outage triggers others poses a significant threat to critical infrastructure, from hospitals to transportation systems. This interconnectedness means that a single point of failure can have far-reaching consequences. The recent solar storm, a mere whisper of the sun's potential fury, underscores the fragility of our technological interconnectedness. It serves as a stark reminder of how dependent we are on these systems and how crucial it is to protect them.